which Jonathan went and got a sample of it, so we have to wait for him to get back. But this is just a stir plate, like a magnetic stir plate, like that one is. It just spins around.
And that's out of tank.
This is the first one.
Okay.
Over there.
There's a restroom right around the corner. Turn to your right, to your right, to your right, to your right.
So what I'm going to do, I don't know about this sample, but the samples y'all sent me before couldn't be done easily, concentrated wise. So I'm going to pull and I'm going to dilute the sample he bought because that's what I had to do in the lab when I was doing testing.
So you're basically going to figure out how much is in those tanks and just make a little mock-up of.
Right, so that's what's in the tank. Now, granted, like I said, I'm going to dilute it right now because it's so concentrated, but like in a normal, once you get just your rinse water. So what I'm going to do is fill this up to 1,000 mils, okay? And so what we do is that way every milliliter I put in here, we know we're going to treat it as a gallon. So it'll be a gallon per 1,000. So that's how you can scale it up.
Okay.
You have to say, well, your tank out there is, say, 4,000 gallons. So whatever, if I put 1 mil in here, that means I got to put 4 gallons out there.
Okay.
Because that tank is,
4.
it's just a scale. So anyway, so I'm going to add, so I'm going to roughly add 200 mils, because like I said, I had to dilute it in our lab. If it's just rinse water, you wouldn't have to do this step. Are your pipes froze? Was the water running in there? Fill that up just to 1,000. So, again, with just rinse water, you shouldn't have to do this particular step of it. Well, so what I want to do, and get my different chemicals out.
Do you want me to open this one, Chris?
No, I don't need that one. I need the other two. Not the pink and yellow.
Now, what is that one?
This is caustic, so this is just going to raise the pH.
Correct.
This is sodium.
This one right here?
Sodium.
What is
No.
it? pH.
Should have a, that lid, that one.
This one?
Okay. So he just filled that up to 1,000 ml. So like I said, we're just going to treat that. That way we can treat it as 1,000 gallons. So we're going to cut the stirrer on. Hopefully the pH meter work. I should have checked that at the beginning.
It should work.
Put the pH meter in there. Let it sit for a few minutes.
Don't get my pH meter dirty.
It's reading all H's for temperature. Maybe it's too hot. So what you can do is you can buy these at Walmart. They're diabetic syringes, but what they work good for is because they're a 1 mil syringe, but they're calibrated by 0.1 mils. So you may not need a whole mil. So they're just standard. They're about the cheapest place you can get them, really. I mean, you can get fancier ones, but these work just as good. You don't need the needle part. We're just using this little part. So what I'm going to do first is put in calcium chloride. What this is supposed to do is help pull out any phosphates. Okay, so in this particular case, I'm just going to do a whole mil. But what you can do is, once you start doing more testing, you can sit here and if you have the way to, like the Hawk unit where you can do your own testing in here, you try a mil. If you still have high phosphate contents, you might go to 2 mils or 1.5 mils. And so that way you can tell, you can tell the treatment. That tank wasn't bubbling, was it? It was just sitting. So the solids, some of the solids may have fell out of it. So I just put, well, I'm gonna put 2 mils in just to make sure. I might have to do this again once we cut the air on that tank, but we'll see what this does. So we put 2 mils of that in there. And like I said, that is just to bind up the, to help it phosphate tank. So now what I'm going to do is adjust the pH up to, give me one of the little syringes. Up to 6, no, the other one. So this one, you really don't, you can measure it, but I'm just bringing the pH up to about 6.5, 7.
What's it at now? 3?
It's at 5. Let's come back down.
And this is what, 50%?
Yeah, this is 50% silver dioxide. So we're just gonna let that mix for a minute or two. Another stir down there. You didn't bring your flashlight in, did you? So you can kind of see it's making like little flakes down in there. The best way to do it is with a flashlight because you can see it better. It's hard to see, but you see them kind of things moving. So we're gonna let that mix for a little bit, and drop. So the pH is let's come back down. So we'll just let that stir for just a few minutes. And this is what you have to do. That's one thing about batch testing is you can do this. Then you take the effluent, check it against your, whatever test you want to run on it. And then, theoretically, if you do the same thing out there on a bigger scale, it should give you the same results. But then after you do it out there, you pull a sample back here, bring it and test it again.
And when you say out there, you mean in the large tanks?
In the large tanks, right. So all we're doing is like a small model of what
Right.
we plan on doing out there. But you would think, okay, if I can do this to the small batch, if I do the exact same thing out there, it should give me the exact same results. But then you just, once you've done, you pull the sample from out there, test it in here. And then like I think he said once a week you're supposed to get tested. So once a week you can send the sample to whoever the lab user was. And ideally, their numbers should match your numbers. If their equipment's going to be more accurate than yours, but yours should still give you a good baseline if you're within range. Okay, so now I'm going to bring the pH up to about 9. It's still been 6.5, so it's been a few minutes. I'm going to raise the pH up to around 9.
And why are we bringing it to 9 and not 7.5?
Because 9 helps, we're going to add this chemical.
Okay.
And it helps two things. One, it helps with binding that with the metals. And it also helps the phosphate start precipitating out of solution versus staying in solution.
Okay.
Because what we're trying to do is get the crap out of the water.
Right,
So
drop it down.
by bringing the and 9 still is dischargeable. So it isn't like it's making it a hazard because it's on the high side. It's still within your range. So we're gonna just let that. Okay, so this is gonna. So we brought it up to roughly 9. It's 8.7 something. This is going to lower it, so then we're going to have to add a little bit more once we put this in. So I'm just going to put, say, a mil of this in. And like I said, I'm just doing numbers we messed with the other day in the lab. You may determine these numbers need to be changed, but this is where I would do as a good starting point. Okay, so I'm putting that in there. Okay, you see the pH drop back down, so now we're going to raise the pH back up. Should come back down. I think it's blowing in. I thought it was blowing out. One of those rooms was stinking cold. I can't figure that out. So if you really can't see it, I'm just gonna make sure off a minute. It's kind of hard to see. I don't know if you can see it in the camera. But you see them little, I mean, it's like real fine. It's real fine. You gotta look in the, see it right there in the light?
Oh, yeah.
Okay? So we're gonna let it mix a little bit longer. So what it is now what you wanna do is all them little tiny things like that, you wanna group them together so it's easier to filter. Because see how fine that was?
Which is basically the flocking.
Right. So that's what we're going to do. I'm going to let it mix a minute or two first. And the only thing we, like I said, so what we'd have to do is once you get your water going, do these type of tests, then test the nickel level, the zinc level. If it's still too high, I might need to add more of that. Or then make another, what we call a metal polisher that helps just remove the small residual metals left that you could add as well to help lower the numbers just a little bit lower. And like I said, this is just treatment. We determined there's other scenarios you could possibly use, but this one seemed to have a good result in the lab. But see, it doesn't look like you've done anything. It just looks amberish or what have you. But like I said, when you slow it down, you can see it. And that's a downside to the way with your air mixing, is because there's so much agitation to it that you're really not going to see it well. And that's what Chris was talking about, because your tanks are like I have that yellow hue to the side of them. You can't tell what the sludge looks like because it's at the bottom of your tank. Where when we finish this, you'll see it should all fall to the bottom. But it should only take somebody like an hour at the max to do one of these jar tests to say, okay, yes, this is good, this isn't good, and then, okay, do I need to tweak something? And that's what's nice about these syringes, is I just did 1 mil, but if you went up to, say you want to put 1.4 mils, if you think, you got a lot of the metals, but not quite all of it, maybe just increase it just a smidgen, and then on the tank, you can just scale it up by that amount. Alright, let me see that, the 982. See what this does. And is that retained bottle, is it solid or is it liquid? It might be down one of the jars. Yeah, look at one. So now I'm going, this is the polymer to help just drop that in there. Hopefully it'll work. What do you think? See how it's getting bigger?
Oh, yeah.
See, so you see the side, but
Oh, yeah.
so I added, that was 1 mil. So I'm gonna add another one just to so that's 2 mils. And once your lab guy gets working with this type of stuff, he'll get more familiar with doing it. See how it's even bigger? Is that showing up in there?
Yep.
Okay. Actually, I can cut it down a little bit. You can see it better. Okay. Okay, but that's still too. I mean, it's bigger than it was, but it's still too small to flock. I mean, really, for a filter press. A filter press, you want as big of a. The bigger it is, the easier it is to filter because it groups all the little stuff together. Okay. So we're just gonna let that mix a little bit. And all that's doing, that polymer does is bind all the little.
It's a binder,
and
yep.
builds it bigger.
Excuse me.
That's why it's nice to see, because without a flashlight it's hard to see it. But see, when you put a flashlight up, you can kind of see what it's doing. So I wish they make lighted ones of these, but I haven't found one. So, but you just get your little flashlight. And let's see. So when you cut this off, okay. All right. See how I build build it up some, but still that's not.
It's still small.
It's still small. So what we're gonna do?
It's 470.
But see how it is settling down, but it's real slow. So we're gonna see if we can. All right,
475.
yeah, the retain bottle. So what this is, you have a tank up the top, the little yellow tank, the only thing that actually has a mixer in it. What that I think was used
The flocker.
for. Right, is that's what this is. So this is a flock that I've already pre-diluted. Let me get this around at 1%. So I took basically the product and made a 1% dilution with it, and so we're going to add that to it. Okay, so we got one. It might be too cold. Let's see what it does. Okay. So see how it's getting even bigger?
Mm-hmm.
Okay.
Oh, head waste treatment.
I'm gonna cut that down so it doesn't shear it up. Add 1 more mil. Let that mix a little bit. It should build it up a little bit bigger as it goes.
It's about how my chest feels.
Now the only thing about using too much polymer is you get to a point where you're using too much polymer, and it will it actually hurts your filter press, because what it does is it helps bind the filter press up. So you just don't want to put a slam of polymer in there, and it start binding up your filter press, causing it to take forever to filter. Okay, so it's. But as you can see, I mean, it's pretty good size. So what you would have to do, and I think that sample polymer was a little cold too, because in the lab it got a little bit bigger. But what you'd have to do now is, once you get this done, my thinking would be you let it sit overnight. Okay, so that way all this, but see how it's falling pretty fast?
When you say that, you mean this or the tank?
The tank, I'm sorry, the tank outside. So,
Okay.
because this is just a a little tiny
Mock-up.
You got a big tank out there.
Yep.
It's going to take a while for all that to fall down. I mean, it fell down. I mean, there's a little bit here, but 20 seconds or whatever. But if he treats it throughout the day, what I would do is that night, let it sit overnight. It can all settle down really good. Start packing that, not packing, but settling that flock down to the bottom, and then you have a decant valve on the tank, so you can decant. See right now you got a little bit of flake up here, but if all that flake was gone, you could decant the top half and just send the bottom half through the filter press. Okay? So that would be the plan, and then this looks like a lot of flock, but you got to remember look how airy it is. A filter press packs it
in.
So it does look like quite a bit of flock.
But when it comes out,
But yeah, once you pack it,
It's nice and fluffy now.
yeah, nice and fluffy. But once you solidify
kind
it,
of like your pillow when you get in bed and it's nice.
so
And the next morning it's flat.
that's what when we call doing like a jar test or a lab test, because in that way you can test. Now what you could do is what she would do down here is filter this top part. The person in your lab filter this top part, and then he could use and do some tests on the metals to see what metals are left in here.
Okay.
Same thing out there you're going to do when you do your weekly samples. Once it goes through the filter press, it's been filtered. So you take a sample out of that and send out to your lab and have them tested.
Okay.
So you do want to filter this before doing your little lab testing, just to make sure there's any, like, see a little bit of particulate right there, that's still kind of levitating. You'd want to just run it through a small filter and then have your guy here do some metal testing on it as well. And I'm not sure what type of metal testing they do in the plating line, but he should be familiar, I would think, with some type, doing some type of qualitative or quantitative metal testing. So that's a brief scenario. So what you would do with this is okay. So I brought the pH up to roughly 6.5 with caustic. So you would just have to use that with a pH meter, how much you would need. You can get a ballpark if you use one of these syringes to see how much it took. We'll just bring it up to 6.5, by however much it takes. Use a little pump and it just trickles it in there with a pH meter, because most of the time you have a pH meter submerged in your tank and it's constantly reading. So you have that pH meter is what controls how much sodium hydroxide or caustic you put in the tank. And then I actually put 2 mils of the calcium chloride. So when you do that in your tank out there, if it takes 4,000 gallons, since it took 2 mils per thousand, it would take 2 gallons per thousand, so it would take 8 gallons per thousand. Then bring the pH up again, because we would like to add the calcium chloride around 6.5, so it can react good with the phosphate before we bring the pH up. Okay, so that's why I added the calcium chloride at that lower pH. Then brought the pH up higher, added ferric, helped bind up the metals, and then from there let it mix a while, and then basically we're just trying to build the flock so we can filter it better. Okay, so that's a quick overview. So what I used in this particular beaker was 2 mils calcium chloride, 1 mil ferric, 2 mils of the first polymer just to bind it a little bit, and then 2 mils of a 1% polymer to build it up to make it filterable. Is that clear as mud?
Yep.
Clear as mud.
Clear as the water in there.
Clear as that water in there. So when we talk about jar testing, that's what we're referring to. And then the same thing is, say if you had an issue or couldn't figure out something, or one of the metals was still too high, you could either come back here and do more of this testing and say, well, maybe I need to increase this by a 0.5 mil or 1 mil. The other thing you do is just pull a water sample from your system, send that to me, and I do the same thing in my lab, but I have more chemicals than just the 4.
Okay.
You only have the 4, or whatever, however many you started using, but we have other chemistry that may do a better job, or you have a certain waste stream that may need another chemical or a different chemical to work better. Okay? That caustic's already freezing.